Grading and evaluating dull bits is one of the most critical responsibilities for a well site leader or drilling engineer. It provides an industry-standard common ground for evaluation and performance tracking. By understanding the story every bit tells, we can identify operating practices to optimize performance, improve bit selection for future runs, and ultimately reduce drilling costs. Hello everyone, I'm Brighty, your rig systems lead. Today, we are going to master the IADC dull grading system step by step. This system is composed of 8 distinct tests or columns. Each one provides a vital piece of data about the bit's condition. We will go through each of these 8 criteria slowly and professionally, showing you exactly how to perform the grading on your rig. Our objective is for you to leave this session with a clear understanding of the 8-column grading format. We will learn how to measure tooth wear, identify specific failure modes, determine the precise location of wear, evaluate seal integrity, and accurately measure gauge reduction. Let's start with test number 1, the inner rows. Test number 1 focuses on the inner rows of the cutting structure. These are the teeth or elements that do not touch the wall of the hole. When you begin your inspection, your first task is to report the condition of these inner rows using a standardized scale. Let's look at how we measure this wear accurately. To grade the inner rows, you must examine all the teeth located between the nose of the bit and the gauge row. We use a graduated scale from 0 to 8. A grade of 0 means the teeth are in new condition with no loss of height. As the teeth wear down through abrasion or damage, the grade increases. A grade of 8 indicates a total loss of the tooth height. For steel tooth bits, we measure the linear reduction in height. For insert bits, we measure the reduction due to lost, worn, or broken inserts. Look closely at this scale. Test 1 requires you to average the wear across all inner rows and assign a single number. Precision here is key to tracking how different formations affect our cutting structures. Test number 2 is the evaluation of the outer rows, also known as the gauge row. These are the teeth that actually touch the wall of the hole. The condition of the outer rows is critical because it directly impacts the bit's ability to maintain the correct hole diameter. Let's look at how we grade this row. Just like the inner rows, we use the 0 to 8 scale for the outer rows. You are measuring the reduction in the cutting structure due to abrasion, chipping, or breakage. A grade of 0 represents no loss, while 8 represents a complete loss of the row. Consistent grading of the outer row helps us understand if the bit was underperforming or if the drilling parameters were too aggressive. Test number 3 is where we identify the major dull characteristic. This is perhaps the most important part of the grading process because it tells us why the bit looks the way it does. We use a standardized 2-letter code to record the primary failure or wear mode observed on the cutting structure. There are many 2-letter codes, but some are more common than others. BT stands for broken teeth, which can be caused by improper bit selection or junk in the hole. ER indicates erosion, often due to excessive hydraulics or abrasive formations. When performing test 3, you must choose only one 2-letter code that represents the most significant dull characteristic of the bit. Look at this example of broken teeth. Notice how the cutters are fractured. This BT characteristic might be typical for certain hard formations, but excessive breakage requires a change in drilling parameters or even a different bit type. Correctly identifying the characteristic in test 3 is the first step toward a technical solution. Test number 4 defines the location where the major dull characteristic from test 3 occurs. This helps us pinpoint exactly which part of the bit is struggling. We use a single letter or number code to specify the location, such as the nose, middle, or gauge rows. The nose row, coded N, represents the centermost elements. The middle row, M, includes everything between the nose and the gauge. The gauge row is G, If the damage is spread across the entire bit, we use A for all rows. Additionally, you should identify which cone is affected. Remember, the number 1 cone contains the centermost cutting element, and cones 2 and 3 follow clockwise. Test number 5 reports the condition of the bearings and seals for roller cone bits. This is a critical check for bit integrity. If a seal fails, the bearings will quickly follow, leading to potential cone loss. We use specific letter codes to indicate whether the seals are still effective or have failed. Grading seals requires careful inspection. E means the seals are effective and the cone rotates smoothly. F means the seals have failed. Look for warning signs like grease weeping from the seal area, or a cone that is locked or catching when rotated. If you cannot determine the condition, use the code N. Mastering Test 5 ensures we pull the bit before a catastrophic failure occurs. Test number 6 is the gauge report. This test measures any reduction in the bit's diameter. To perform this test accurately, you must use a nominal size ring gauge. We follow a specific technical procedure called the 2/3 rule to calculate how much the bit is under gauge. Here is the step-by-step procedure. First, rotate each cone so a gauge tooth is at the maximum point. Place the ring gauge so it touches 2 cones firmly. Then, measure the gap between the ring and the 3rd cone. Take that measured distance and multiply it by 2/3. This final figure is the amount the bit is under gauge, which we report to the nearest 1/16 of an inch. Test number 7 allows you to record any secondary or other dull characteristics. This is your opportunity to note any additional wear or damage that wasn't the primary failure mode identified in Test 3. It provides a more complete picture of the bit's life in the whole. For Test 7, you use the same 2-letter codes as Test 3. For example, if your primary characteristic was broken teeth, but you also notice significant heat checking on the cutters, you would record HC here in column 7. This secondary data is often used by engineers to fine-tune drilling parameters for the next section of the well. Finally, test number 8 records the reason the bit was pulled. This identifies the operational event that terminated the bit run. Whether it was a planned BHA change or a sudden equipment failure, this code completes the bit's history. Common codes for Test 8 include TD for reaching total depth, BHA for a bottom hole assembly change, or PR if the penetration rate dropped below an acceptable level. Using these codes consistently ensures that everyone on the rig and in the office understands why the run was terminated and how to plan for the next one. To be truly professional, you must be thorough and consistent in your grading process. Always start with cone 1 and work your way clockwise. Examine the cutting structure, rotate the cones to check bearings, and finish with a precise gauge measurement. High-quality documentation and photos are the final, essential step in every evaluation. Let's recap our 8 tests. Measure the inner and outer wear from 0 to 8. Identify the primary dull characteristic and its location. Evaluate the bearings and seals. Measure the gauge using the 2/3 rule. Record any secondary characteristics. And finally, note the reason the bit was pulled. Mastering these 8 tests is your key to drilling excellence. Thank you for your attention during this detailed training session. By applying these industry standards step by step, you are helping to improve safety and efficiency across all our operations. Remember, a thorough evaluation today leads to a better well tomorrow. Stay safe and stay professional out there.